Hello students, this is Mr. Bornheimer. Let's go ahead today and look at 8-5, area and circumference of circles. I want you to start by making a circle on your paper. Very good. Now, with that circle, we are going to reintroduce some key vocabulary that we had talked about in the previous chapter, but that will be very important to our discussion today, which is centered around area and circumference, which is also known as kind of like the perimeter of circles. Okay, so there are some key terms that come back into play here that we're going to want to focus on. So first, remember that all circles have a central point, and that if you draw a line from that central point to the edge of the circle, that is the circle's radius. If you draw a line from the edge of the circle through that central point to the edge, that special chord is known as the diameter. Now, a chord is any line that cuts across a circle whose endpoints are on the circle. Okay, so a diameter is technically a chord. It's the longest chord you can have in any circle. It goes through that central point. So we have radius and we have diameter. Now, the area of a circle is going to refer to that region inside of the circle here. Okay, so I've highlighted that. That's going to be the area of the circle, and that's that region, okay, that area, kind of like the similar area problems where we're talking about, you have an area rug, okay, it's confined by the edge of the circle. And then there is the circumference. And the circumference is the circular path that goes around the outside of the circle. So this would be the circumference. Okay, and again, it's that circular path that goes around the outside of the circle. Now, there are different things we need to remember about area and circumference. Area is just that, something that gets measured in units, but more so units squared. So area is measured in units squared. Examples of this could be inches squared, feet squared, meters squared, etc. And then there is circumference. And circumference is just measured in plain old units because it's a lot like perimeter, right? So it would be inches, feet, meters. Okay. Now, when we are looking at a circle and we want to figure these things out, area and circumference, we need to look at them each in their own way. Area is going to have its own unique formula, that is pi r squared. Circumference is going to be 2 pi r. Now, notice that in each of these formulas, the only thing that you need to know is the radius. That's it. That's the only piece that you need to know when trying to solve either the area or the circumference. Now, sometimes you're not given the radius. Sometimes you're given the diameter. And if that is the case, you need to remember that a radius is half a diameter. So diameter equals 2r, or 1/2 d equals r. Again, half of the diameter equals the radius, or 2 radiuses equals the diameter. So, if you're given diameter, you can find radius, and vice versa. Now, let's go ahead and apply these two formulas to a problem involving a circle with radius of 5. Okay. In this particular scenario, if we want to find the area, we start by writing our equation, pi r squared. Now, you should know that pi, and I'm going to make a little note off to the side here, that pi can be represented two ways. It can be represented as 22 over 7, which is not exact but close. Or it can be represented as 3.14. And then that number goes on forever because it is an irrational number. Now, I do want you to note that for our purposes, I would prefer that you use 3.14 unless the textbook tells you to use 22 over 7. Either way, you're going to have to either way, you're using a rounded, approximated value for pi. If we use the true pi, then we'd have to use the pi symbol on our calculator, which takes into consideration all of the digits of pi. And 22 divided by 7 does not give you pi, it just gives you something very close to it. But pi is something that the ancients discovered that kind of was part of a relationship between diameter and circumference. And it's helped us to solve circles now for over thousands of years. So area equals pi r squared. What we need to do is we need to plug in the values that we know and solve this problem. So this is going to equal pi 3.14 times 5, which is a radius, times 5, which is a radius. Because remember, r squared that means that you just take r and you multiply it by itself. So this is going to equal 3.14 times 25. Okay, now we can multiply these two values using our calculators. 3.14 times 25. That will give us 78.5. Lastly, we need to go ahead and include our units. And because I didn't give you any units in the problem, you would put u squared to finish this out. Okay, now to find the circumference, you would do 2 pi r. Again, plug in what you know and solve. This is going to be 2, okay, times 3.14 times 5. If you put numbers in parentheses next to each other, like so, that is telling the person doing the math that you are doing multiplication. This is the same as 2 times 3.14 times 5. So 2 times 5 is 10. So this is the same thing as 10 times 3.14. And anytime you multiply it by 10, you just have to move the decimal. So this is going to be 31.4 units is my circumference. And it stays units because it's a distance. Circumference is a distance. It's the distance around the circle. So now I've completed my two calculations for a circle with radius 5. Now what's really neat about this, again, is that any circle with a radius 5 is going to have an area of 78.5 units squared and a circumference of 31.4 units. And that doesn't matter if it's 5 feet or 5 inches or 5 meters. Okay, so any circle with radius 5. All right, let's look at another problem here. Let's say that I have a circle. Oh, not a circle. There we go. Boy, circles are becoming harder and harder to draw. Let's say I have a circle, and I want to find its area and circumference, but it has a diameter of 7. Okay, the first thing you need to remember is that we are always looking to find the radius. That's the value that is the most useful to us. So we'd have to take this diameter and we have to cut it in half. Okay, we really need just this red part here, which is the radius. Now, half of 7 is 3.5. And yes, I picked a number with a decimal on purpose, so it'd be a little bit messier. So let's start with the circumference. C for circumference equals 2 pi r equals 2 times 3.14 times 3.5. Okay, we can go ahead and multiply these together. 2 times 3.14 times 3.5 equals 21.98. Now, if we do round that, and we can in this particular situation, the circumference is approximately 22 units. Area, capital A, equals pi r squared, is going to equal pi, which I should just make 3.14, times 3.5 times 3.5. I suggest in your own work and notes that instead of trying to use some sort of squared key on your calculator, you just multiply the value by itself, because I think that gives you a better understanding of the differences between circumference and area. If you also show it in your work like this, it's very easy to see where you've made a mistake. A lot of students think this means to multiply by 2. It doesn't. It means you multiply the number by itself in the problem. And if you show it like this, you're more often than not going to make fewer mistakes when doing problems involving the area of a circle. Okay, let's go ahead and multiply this out. 3.5 times 3.5 times 3.14 equals 38.465. 38.465. Okay, and because our value here is rounded to like one place past the decimal, we can do the same thing here. We can round to one place past the decimal. So our value should be 38.5 units squared for this particular circle. So now we have found the circumference, and we have found the circumference, and we have found the area of this circle with radius 3.5. All right, last problem I want to show you is a little bit of a trickier problem. So I just want to make you aware of it because you're going to see other problems like it, and potentially even on one of your puzzle assignments. Let's take, for instance, a figure like this. And draw it here for a second. You might want to wait to draw it until you see what I'm drawing. Okay. All right, there's a circle there. And I am going to actually erase this portion of it. I want us to find the area of this figure here, okay? And it's not that hard once you see it the first time, but this is not what we call a regular shape, right? It's basically a rectangle that has had a semicircle chunk taken out of it. And if we want to find this yellow shaded region of this particular irregular figure, we're going to need to break this problem up into parts. So the first thing we're going to want to do is we're going to want to look at what would have been the area of this rectangle or square. That's what we need to determine first. So if it was a normal rectangular square, the area would have been base times height. And the base would have been 1, 2, 3, 4, 5, 6, 7, 8, 9 across. So it would have been 9 units by 1, 2, 3, 4, 5, 6, 7, 8, 9 units tall. So it was a square. And if you multiplied those together, you would have gotten 81 units squared. Now, that's what it would have been had we not taken a chunk out of it. What we need to do now is we need to say, okay, well, how much of a chunk would this area, which is a semicircle, how much would that have been? And in order to figure that out, we're going to need to look at the radius of that particular semicircle. The radius would have been 1, 2.5. So the area of a circle is pi r squared. The area of that semicircle will be half of that. It will be, so the area of a semicircle is going to be half pi r squared. So we take that. Half times 3.14 times 2.5 times 2.5. Okay, to be clear, half because it's a semicircle, 3.14 because it's part of the equation, the radius times itself. So all of this is going to give us the area of this purple region. Okay, now that's not terribly challenging. 0.5 times 3.14 times 2.5 times 2.5 equals 9.8125. 9.8125. Now, because our problem has only one place past the decimal in its original numbers, we should probably round this to being about 9.8 units squared. So you might be thinking, hey, we're done. Well, not quite. What we need to do is we need to take the area of what would have been the square and we need to subtract the semicircle. So the area of this square would have been 81, and we are going to subtract 9.8. And that tells us that we have an area of 71.2 units squared. And that is the yellow region. So knowing how to work with circles can be useful, especially if they come into play in scenarios like this, where you're trying to subtract part of a figure that may end up being part of a circle. Okay, and there are other types of problems like this. The classic problem you will see in high school is if you have like the box underneath the basketball hoop and then, the free throw line, okay? And you've got to figure out the area of all of this. Okay, this is a classic problem that you will have to do in high school. So just remember, you're going to have to work with semicircles. You're going to have to find their areas. So when that happens, okay, this kind of half comes into play. All right. Thank you for watching, and it's now time for you to try some problems on your own.